Hello, everybody. Last time we looked into what is a BSD system kernel look like. Okay, so what are the different types of files that is available? How we give user commands, how we give system commands, what is a shell, what is a B shell, S shell, and other things. Okay, shell layering is there for different kinds of operating. Now, what is a process table? What is a file table? Okay, and then what the different kinds of tables I told you already about 3 or 4 different types of tables. Okay, those are the basic things of manipulating the entire BS operating system. Okay, BSD operating system. It's kind of Unix kernel and things like that. Okay, so shell is the basic thing, which is the kind of system, system kind of operation will be done by shell, and other things will be layered over that. User commands and other things are all. So they have different libraries for each one of this, for user interface kind of thing, for system commands, for network commands, and for other kinds of commands of system management commands and other things. Okay, so you're going to basically manage 4 different types of tables, which I told you: process table, file table, then process table, file table, then what else you are going to manage, then basic BIOS table, that is basic input output table, IO table. So process table, file table, input output table, IO table, then another one is there. Okay, so these are the four. Some of the interrupt tables also are there. Interrupts are things which come right in the middle to when you're doing some kind of work, those kind of things. Other tables are also there. They are not very critical about the whole thing, but we are going to look some of the thing which is very important in case of operating system, how to develop an operating system and things like that. This is the second lecture about the things. So previously you have to go look at the structure of the BSD system when you are looking at this. Today we are going to talk about specifically about what is called an inode. Okay, what is an inode? Okay, basically what is an inode in Linux? Okay, you store your information in a file, and the operating system stores the information about the file in an inode, sometimes called as inode number. Okay, an inode is metadata of the data. Okay, so if you want to store something, you have a hardware, and you have the memory for the hardware, and you want to store a files over that. Then what you have to have what is called an inode. So inode is the one which is, if you want to create a process table, if you want to create a file table, want to create a other kinds of tables and other things, the first thing you do is what is called an inode. So inode is very critical. Is called what is called It is called an information node or something like that. It's called the information about the file. So information about files, and sometimes called metadata. So you can even say it in another way: an inode is a metadata of a data. So you have this basically the hardware interface to the, basically a hardware table, hardware kind of numbering system over to the software kind of map that is going to be present. So if you say remove file A B, so where does A and B come from? Okay, so A and B is the user level of understanding what is A is a file, B is a file. So move file A to B means it has to understand. So that command has to be understood. So those command structures are there, but basically how you do it in a hardware, how it is going to be moved in a hardware. So first thing you have to make what is called a file format. So first they produce the entire structure of the memory system into what is called a file format. So file format is the first thing. So in order to do file format, first thing they use what is called an inode. Okay, inode is the basic information node. Okay, information node means it's a kind of the kind of a inode structure of a directory. Okay, so if you want to do a directory, what is the inode structure for a particular directory? So it can be inode structure for a file, it can be inode structure for a directory, or it can inode structure for other things. Okay, basically the inode structure will have only structure of a directory. Okay, so this is the basic inode number 34700036. So .net is 34700037. .net is .3470017 folder 1 folder file 1 file 2 file 3 etc. Okay, so this is the inode number for that. So inode is a number, okay, numbering system for a file system, okay, which contains the metadata of the information about the file, because you cannot keep the file names and all tagged. While doing it in the hardware, you cannot do all those things, okay. So instead of that, they have what is called a numbering system over which it is. So first thing is your disk, entire disk, your memory, okay, your internal space, everything is first a kind of formatted into a directory structure, and that is what is about a inode structure. So inode is a basic file system of the hardware aspect of a memory unit, which you can map as a metadata over for the actual file system which is going to be present in the disk, or it is going to be in the memory locations and other things, okay. So the structure cannot be represented as a kind of, you cannot just go over a tree and things like that. So tree structures won't be there. So instead of that, they do what is called a numbering system, okay. So they do the numbering system in order to map the whole thing from the hardware to the software, okay. So that is why where we need the inode structure. Inode structure of a directory we saw. Now we look at the inode structure of a file. Inode structure of the file: mode, owner info, size, timestamp, direct blocks, indirect blocks, double indirect, triple indirect blocks. So it goes up to the level of triple indirect, double indirect, indirect blocks, direct blocks, timestamping, size, order info, those kind of. So the basic things that will be in the inode table will be having all this for a particular file, okay. So in order to access over the network or anything, okay, over the network, if it is the NFS file system, though there are different kinds of file system. I told you, network file system, RPC, remote file system, then we have a hash table kind of file system, different kinds of file systems, and queuing block file systems, queue kind of structures, which are all there, okay. Those things about the whole thing will be first developed into two major structures. One is the directory structure for the inode mapping, and then the inode structure of a file. So these are the two basic things of a direct block patterns which you can use for it. It's just a map between the hardware and the kind of software you're going to write. So triple indirect block pointers. So these are all triple indirect block pointers, and you have double indirect block pointers. These are the kinds of things. So you have two major things. One is a directory structure, okay, inode directory structures. Another inode structure of a directory. Then you have what is called an inode structure of a file, okay. So these are the two major structures of inode, okay. So these things will be used to map the entire metadata of your file system onto the hardware, okay. So that is why the hardware kind of components is directly mapped onto it. It is a kind of mapping. So they allocate some kind of space. All the space allocation will be done as chunks of what is called a memory chunks, okay, memory chunks, or some kind of malloc or something like that, okay. So those kind of file systems will be there. So this is the first kind of initial kind of filing system or file blocks that will be created, directory blocks and file blocks, which will be first created, and it will be mapped on to your actual file system, where you can use your own names, like copy a comma a means a file, b means a file. So copy a comma b, it knows where to find the file name A and B. So the inode will be the one which is helping all those things, which is directly mapped onto the names or to the files and other things, okay. So the naming and other things, timestamp, indirect blocks, double indirect, triple indirect, these kind of number structures will be first given, okay. So inode, you have to understand what is an inode. Inode is the basic things of file system for a particular kind of disk file system, or kind of memory allocation for process tables, and all these things will be used only using inode structure of a directory, okay. So inode structure of a directory will be used, inode structure of a file will be used. These are the two major things that you will be using for any kind of access to a particular kind of file table, access table, remote file table, everything. Okay, so that is why you should be very careful about structure allocations for inode structure of a file and other things. So the memory chunks will be created as a kind of file. Okay, so the memory chunks, they will be accessed only as a kind of inode number, so they will be accessed only. So when you are accessing a particular, say you say file, move file ab, so when you say a, then that means that it has got a inode structure entry which corresponds to a particular number on the file table, or a metadata is stored in a form of number. Okay, so that number, how, so it will know exactly where to find that particular number, get all the file file things, and then display it over the screen. So if you are accessing a file, say you say display the file x. Okay, so that file x will be there as chunks of blocks, as a hardware chunks of blocks on the memory storage or some places. Okay, so the inode will have a direct entry linking to all these things. And if it is continuous kind of thing, so if the file is too huge, then it uses a directory structure, and then file links within that. So triple indirect blocks are pointers which are going to have huge files. So double indirect blocks are smaller file systems and things like that. Indirect blocks are just pointer to different kinds of files. So single file or small block files and things like direct block pointers. These are the basic things you have to understand about a file system. Okay, so the basic things that will be there: owner information, size of the thing, timestamps, and block size. Okay, what is the block size? Okay, and mode. Okay, so these are the basic things: mode, owner info, size, timestamps, block size. So this will be the thing which will be used for as a kind of file system, inode structure of a file. So for inode structure of a this thing of a directory, you have what is called, let's find out what is the inode structure of a directory. Directory will have inode number. Okay, so inode number will be there, then dot will have some specific inode number, then file 1 2 will have different kinds of number. Okay, so the file directory structure will be a straightforward kind of thing. So folder 1 will have one kind of number, folder 2 have file will 2 will have, folder 2 will have different kind of number. So there's a direct map in case of directory structures. Okay, directory, so each file and each directory is all directly mapped onto a particular number. So that number, whether it is a file or a folder, depends on what is the number that is given. Okay, the number mapping. Once the number mapping is clear, then it goes, if it is a folder, then it will directly get the folder access. If it is a file, then it goes into inode, will go into what is called the file structure. File structure, where it is kind of, how to, the file structures have inode structure of a file has mode, owner info, size, timestamp. So double reading for a particular file. Okay, indirect blocks, double indirect, triple indirect blocks, direct blocks, those kind of things will be used. Okay, so that is how the access will be there. Okay, for directory, it will be directly accessing those kind of numbers straight away. So first thing, directory, all directories will be given a number. So the directory allocation will be the first thing that will be done. So memory allocation will be done for particular directory structure, and a direct mapping will be done. Then after that, indirect mapping from the directory for files alone will be done by file system table, and from the file system table it will be accessing double blocks, triple blocks, or any kind of other blocks, and ownership and those kind of things, whether it is a network file system or other kinds of file system, or direct file access or disk access, and those kind of information will be stored. So the metadata information will be stored in kind of what is called a inode structure. So when you are understanding Unix, you have to know what is a inode. Okay, without an inode, you cannot do any kind of file system table, how to organize the file system, how you create a directory structure, or how how the binary tree structures and other things. Okay, so at the superficial level, metadata level, it will be directly mapped onto these kind of inode tables. Okay, the inode structure of a directory, inode structure of a file. These are the two things you have to remember. Once these things are there, then they will be mapped onto the actual kind of thing, whether it is a remote file system or local file system, or it's a network file system, or any kind of other kinds of file system which will have direct links, and those structures are all different. Okay, though those will be told later, but this is the basic thing of a file system. Okay, so direct access of a disk or this thing, or any kind of thing, memory unit and other things will be done using inode. So you have to basically get the concept of what is an inode and how it is viewed. It is basically viewed, the entire memory structure, everything is viewed as a, even the process structures and everything is a file. So that is a basic statement that is given here. Okay, let me begin this tutorial with a famous Unix statement which emphasizes the main underlying working model of a Linux operating system. The statement is that everything is a file. So first it considers everything into a file, whether it is a disk or a process or any kind of thing is considered as a kind of file. So first thing, it creates a what is called a file table. That is why you format the disk, you format the memory units and other things, virtual things and other things. Okay, so then after that, once you do all the mapping for that particular kind of file tables and directory tables, after that, you overlay the whole thing, the actual file things will come in, and how to access those things will be used. Okay, so this is the metadata of a file system or a directory structure or other things. That the metadata itself is a huge file kind of thing, or huge kind of directory structures with a direct numbering system. It is a kind of numbering system. So you have to know that it is a kind of numbering system, not a actual kind of names or other naming system or other things. It is a kind of numbering system. So that is why it is called an inode. So inode number of kind of that is why it is called an inode system. Okay, that is all. Okay, so the basic concept you have to remember while using a process table, another table, a memory table, and other things will be used. So the first conversion will be what, by from the hardware, it will be first converted into a inode structure of a directory and inode structure of a file. So the directory will have the direct mapping of all the things, and the file will be extension of the direct mapping, which will have a different kinds of numbering system, or which will be having elements to do other kinds of numbering access. Okay, so that number, so for a file which has extension, okay, if it's a huge file, then you have a direct blocks, numbers will be indirect direct blocks will be the first file system, which if it is going to the file is huge, extremely huge, then it is going to use indirect blocks. If it is going to still further, double blocks, then double indirect will be triple indirect. So these are the three levels of indirection of the blocks, so that you can access the entire file, and timestamps for each one of them. Timestamps will be the thing where when it was produced and how it was organized and when it was used. Those kind of information will be given under timestamp. Size is the what is the actual size of the file. Okay, it is 500 bytes or 1000 bytes or 2000 bytes. Those kind of things are there. So owner of the file info, whether it is a user or it is a kind of system, or it is a kind of process table, which is, so the owner information will be given. And mode is the kind of thing which is going to look into what is the keeps information of two things. Okay, one is a permission information, the other type is the type of inode. For example, inode can be a file, directory, or a block device. So three different types so the file system will have the file table will have the mode will give you what are the two things that will give permission information, whether it is whether it is a user or super user or something like other the types of inode. For example, the second one will give to permission information, or the other one is type of inode. So second information will be about the type, whether it's a blockchain, it's a chain device or a directory device or other kinds of things. So these are the, then after that you have the owner info, access to each one of those, size, timestamp, block size, so things like that. Okay, so today we saw the basics about a Unix operating system and what is the first level of tabling that happens. Okay, inode table is the first level of tabling that happens from the hardware to map the metadata onto the software kind of environment where you are going to use the kind of process tables and file tables that you are going to use for actual files and other things. Okay, that is so first thing, it will consider the entire system as a kind of file. Okay, then after that only it will do all the things and do create all the process table and other things. So the numbering will be given direct mapping. Then when you are accessing the process table also, the direct mapping will be there for a particular file table and things like that. Okay, so to understand the thing, you have to understand the inode structure. Okay, in order to understand a system operation, how to map a hardware onto a software kind of environment. Okay, so that is all for today about BSD systems.